Here's a final example of taking the equation of a quadratic function and being able to identify its key components, right? So we have the 16 minus 2x plus 4 squared to quantity x plus 4 squared. And again, let's go ahead and start by trying to find the vertex and then go from there to be able to find some of the other components. All right, now, one thing that we should probably do is we should probably rewrite this into the standard form by flipping the constant and the term that contains the binomial. So let's just rewrite it like this. And I think that's more helpful for us to be able to identify some of the key components. I think we could see that h is going to be -4. We can see that k is 16. And we could say that a is -2 for this. Okay, so it's already put into the standard form, so we don't have to do too much work. And so what that means is that for the vertex, or the vertex is at the point h comma k, -4 comma 16. Concavity is it concave up or concave down. So since a is equal to -2, what we can say is that this is going to be concave down. Okay. And then max or min. Okay, so since a is equal to -2, which by the way is less than 0. All right. What that means is that we have a maximum for our vertex. Axis of symmetry is always at the same point as the vertex, the x coordinate of the vertex. So we're going to say that the vertex, or I'm sorry, the axis of symmetry, not the vertex, although they do have a lot of similar property or at least overlap. We're going to say that the axis of symmetry is at the equation x equals -4. All right. And then the last thing that we want to do before we go through and find the intercepts is we want to find the domain and the range. Domain's really easy. Remember, for every quadratic, the domain is going to be x as an element of the real numbers, so -infinity to infinity. For the range, let's kind of think about this, that we have a concave down parabola and we have a maximum. Okay, so if I were to graph this, let me just go up here and graph it really quickly just so you can see it. We have the point -4, and then 16 is like somewhere way up here. And we said that it's a maximum and it's concave down. So it looks like that this is going to go from -infinity. It's just going to keep going down. And up here is the point -4, 16. And so for our range, I believe, in fact, I know, excuse me, that our range is going to go from -infinity up to 16 inclusive. Okay. Now let's find the intercepts by substituting 0 back in for x to find the y-intercepts. Okay, so last part, intercepts. For the y-intercept, we're going to find h at 0. Okay, and that's just going to give us 16 minus 2 times 0 plus 4 squared. And in this case, that's going to be 16 minus 2 times 4 squared. And that's going to be 16 minus 2 times 16, 16 minus 32, or -16. And so for the y-intercept, that occurs at the point 0, -16. Okay? Or if we just wanted to say that the x-intercept was equal to -16, depending upon what we're asked to do. All right, now for the x-intercepts, that's where we have to set the function equal to 0. We're going to have to do some foiling for this. Okay, so you erase this and this. And so for the x-intercepts, okay, that's where we are going to set 0 equal to 16 minus 2 times the quantity of x plus 4 squared. And remember, to be able to solve this, we have to FOIL. So 0 is going to be equal to 16. Oh, not sure what happened there. Thanks, technology. Minus 2 times x plus 4, or 0 is equal to 16 minus 2, x squared and then 4x, and then another 4x, and then a 16 from this last. Okay. We're going to collect like terms. That's going to be 8x inside. And so one way to write this would be 16 minus 2x squared minus 16x, and then minus 32. All right, so what I did was I distributed the -2 to all three of the terms. Right. Last thing we're going to do is we're going to combine like terms, and we get that 0 is equal to -2x squared minus 16x minus 16. Okay, just by combining these and then rewriting it in the order of the polynomial. Now, to make this easier on ourselves, what I'm going to do is I'm going to factor out a -2 from all three of the terms. Right? And it's going to be x squared. Now, remember, factoring out a negative changes all the signs. So we're going to get 8x plus 8. Okay, and then we could divide both sides by -2. And this is just a process to help us to make it easier when we use the quadratic formula. And so we end up with the equation 0 equals x squared plus 8x plus 8. And so we can use our quadratic formula with a equal 1, b equal 8, c equal 8. That's a lot easier than having all the negative signs that we would have had initially. Okay, so x is going to be equal to the opposite of b, plus or minus the square root of b squared. That's going to be 8 squared minus 4 times 1 times 8 divided by 2 times 1. Right? Or x is going to be equal to -8 plus or minus. We get 64. We get minus 32 divided by 2. We are going to have to simplify this. Right? So that's going to be -8 plus or minus the square root of positive 32 divided by 2. Notice that 32 can be written as the square root of 16 times 2. All right. Clearly, it's also 4 times 8, but you always want to pick the higher of the two perfect squares. That means we're going to get the square root of 16 times the square root of 2, or 4 roots of 2. All right. And so x is going to be equal to -8 plus or minus 4 roots of 2, not 16 roots of 2, excuse me, divided by 2. And then we could break this up. That's going to be -8 over 2 plus or minus 4 roots of 2 over 2. And so finally, x is going to be equal to -4 plus or minus 2 roots of 2. All right. And so if we went back, let me go all the way down here. For our x-intercepts, okay, remember we said that that was going to be -2 plus minus 2 roots of 2, or -4 plus minus 2 roots of 2, just a copy error there. If we went through and we approximated those, because we probably should get an approximation, we could just go right to our calculators and we could say -4 plus 2 root 2. All right, and that gives us about -1.1, -1.2 if I were to approximate it to one decimal place. Okay, so one of the intercepts is -1.2. Okay, going right back here. That's going to be 0, -1.2. And then the other one, I'm sorry, it should be -1.2, 0. Excuse me. I'm flipping everything around. All right. And then if we went through and we said -4 minus 2 roots of 2, that would be -6.8. Okay, so that would be, if I cross this out, that would be -6.8, 0. All right, now let's go through and plot everything on a graph just to make sure that all the stuff that we found corresponds. All right, so if we do so, remember our function, y equals, it was 16 minus 2 quantity x plus 4 squared. All right, and let's plot the axis of symmetry. We had x equals -4, so it went right down there. Okay, you probably remember that we had the point -4, 16 was our vertex. Okay, that looks good. We had the point, I believe, 0, -16. And I believe that was one of our intercepts. Okay, it was the y-intercept. So that looks good. And then finally, let's go ahead and plot our two um, x-intercepts. So that's going to be x -4 plus 2 roots of 2. Right. And let's label that. Oh, it should be comma 0. All right. And there we go. It's right there. That's perfect. Okay. And then the other one, I'm just going to copy this and just change it to a minus. All right. So change this guy to a minus here and label it. And there we go. There's the other x-intercept. Okay. So those are the key components of our parabola. Okay. So hopefully that helps you to understand a little bit about how to identify the key components of a parabola. In our last video, what we're going to do is we're going to go through and we're just going to find the standard form of a parabola given a few of the key characteristics.